Okay, so how do you teach a machine to actually understand language? I don't just mean recognizing words. I mean getting the deep, complex, sometimes really slippery concept of meaning. It's one of the biggest challenges in all of artificial intelligence. And today, we're going to break down exactly how computer scientists are trying to crack that nut. All right, just take a look at these two sentences. The star signed an autograph. Simple enough. Then, the star is a ball of gas. In the first one, you instantly know star means a celebrity, right? In the second, it's a giant ball of fire in space. Your brain just makes that switch effortlessly. It's all about the words around it. That's context. And for us humans, it's totally second nature. But how does a machine do that? How can it possibly move from just seeing a bunch of data, a bunch of symbols, to actually understanding that critical difference? That, right there, is the fundamental problem we're going to unpack today. All right, so let's dive into our first section here. I like to call it AI's lost in translation. This is really where we get to the heart of the fundamental struggle that machines have with, the rich, messy, contextual tapestry of human language. See, the real challenge isn't just about, say, building a bigger dictionary for the AI. No, it's way bigger than that. It's about creating a whole system, a framework, for representing meaning itself inside a machine. We're talking about a truly foundational puzzle in computer science. Okay, so how do we even begin to solve this? Well, this is where it gets really cool, because computer scientists and linguists have developed some incredibly clever tools to tackle this exact problem. And one of the most powerful is something called Discourse Representation Theory, or, DRT for short. So what exactly is DRT? Well, at its core, it's a formal, really structured way to represent both the meaning and the context of language so that an AI can actually work with it. And listen, those are the magic words right there, meaning and context. The whole point of DRT is that it's designed to handle them together, not as two separate problems. And what makes DRT so special is that it gives language a formal structure. Now, don't think of it like a static dictionary. It's more like a dynamic mental model. It doesn't just notice context, it actively integrates it, building this little world of the conversation as it unfolds. It's basically an attempt to map out the way our human brains link ideas together, but in a way a machine can actually follow. Now, this is where things get really interesting, because DRT isn't some lone wolf theory working in a vacuum. Nope, it's actually a key player on a much larger team, and they're all working towards the exact same goal, creating an AI that can truly, genuinely comprehend. And that makes sense, right? To truly crack the code of language, you're going to need a whole bunch of different approaches working together. It really is a team sport for all these different theories and formalisms. And this slide gives us a great little snapshot of that team. So you've got DRT, which we now know is all about context in a conversation. But then you have things like multinets, which are trying to build this universal framework for all kinds of knowledge, not just language. And then you've got these super logical systems like generalized quantifier theory that are really focused on the precise, almost mathematical rules of language. Each one is bringing a totally different but essential piece to the same giant puzzle. Okay, for our last section, let's really zoom out. Let's see where DRT fits into the grand, ongoing story of AI's evolution. Because ultimately, this is all part of the quest for meaning itself. You see, DRT isn't just some random tool that popped up. It's a key character in a really specific chapter of the AI story, a chapter you could call the learning machine. And this part of the story is all about how we get machines to learn, to reason, and to understand, especially when they have to deal with all the messiness and ambiguity of the real world. And even within that chapter, it belongs to a specific research cluster, you could say, called the quest to represent knowledge. It sits right alongside these other big ideas like the logic of knowledge, those multinets we talked about, and the challenge of context. This just shows you how the academic world organizes this massive quest, with DRT being a really vital piece of the whole effort to formalize, well, how we know what we know. And this quote, this really gets to the absolute heart of it all. This entire field is about one thing, the struggle to go from lifeless symbols, the ones and zeros inside a computer, to the rich, living meaning that we all experience every day when we talk or read. It's literally about trying to breathe life into data. So, if you take one thing away from this, let it be this. The crucial point is that discourse representation theory is way more than just some complex academic idea.
It's a bridge. It is one of our best attempts at building a solid, reliable bridge between the world of a machine's abstract symbols and our profoundly human world of meaning. It's what helps turn a simple string of text into an actual, understandable concept.
And all of this leaves us with a pretty fascinating, maybe even a little daunting question to think about. If we actually succeed, if we build machines that can truly understand all the nuance and context of our language, what will they eventually have to say? To us? Definitely something to ponder.